going to go ahead and get started a little bit earlier, just a few minutes, but just get started on this because there's a lot of really good questions coming up in the chat that I just want to be able to address with you guys. So a couple problems that we're being asked to go over. I'm going to kind of, again, go in order of how they were addressed. So the first one that I want to go over, and I know several of you guys have this question, is some double replacement reactions. And in particular, the double replacement reaction that I'm going to go over is a little bit unconventional. So this problem is from our, let's see, what's it called? It was called our reaction in aqueous solution. So hold on, let me get this started. So this is 1J, and it's called reaction in aqueous solutions. And this is a homework. So this is probably the second homework one that we did. So the problem states solid sodium acetate is dissolved in water, and they give you a hint to write water as HOH. So let's go ahead and look at this problem. Okay, so solid sodium acetate. So if I write that out, I'm going to have sodium NaC2, H3, O2, and we said it's solid, plus water. And I'm going to write this as HOH. And this is not aqueous. This is actually liquid, so you want to make sure that you specify that. And so what's going to happen is we are going to produce sodium hydroxide. And this is aqueous. And we are also going to be producing acetic acid, which is HC2H3O2, and this is aqueous as well. So we want to be able to write this in a net ionic equation. So I'm going to be double check that this is balanced. Everything is balanced. So we need to break this up into ions. This does not break up into ions, so this is going to be sodium acetate. This does not break up into ions because that's water, so I'm just going to rewrite this as O2 liquid. And then these do break up into ions, but what we see is that these don't ever cancel out with anything. So our net ionic equation is kind of a strange one, in the fact that nothing, whoops, let me go back, nothing actually gets canceled out. So this is going to be plus aqueous, and this is plus C2H3O2, and that's aqueous with a negative sign. So because these are solid and this is liquid, and they don't break apart, because again, the only thing that breaks apart into ions is aqueous things, nothing can get canceled out. So this actually right here is your net ionic equation. So it is kind of a strange one in that fact that nothing gets canceled out. Josh asked a question saying, how do you know whether it's aqueous, a solid, a liquid, or a gas with a product? So you will know if it's aqueous or solid based off of your solubility rules. So that's when you would use your solubility rules. If you look at your solubility rules, you'll see that sodium hydroxide is soluble and acetic acid is also soluble. And then for liquid, the only liquid that we're super familiar with is water. So water will always be a liquid. Unless it says that it's liquid in the problem, assume that other things are probably aqueous or something like that. And then you will know it's a gas because remember, there are 4 ways that gases produce. So we'll have a gas if we're producing something like hydrogen or oxygen or fluorine or bromine. These are all gases. And we have a few more. There were the 4 examples from notes where gases evolved And I'm actually going to be giving you guys those 4 examples on the test, so you don't need to memorize those. But you do want to know your solubility rules. Or know how to use them, because again, I will actually give you solubility rules on the test, so you don't need to memorize those. Let's look at problems number 1 and 3 on station. Is bromine a liquid? Am I thinking of something else? I might be thinking of chlorine. Bromine is a liquid. I was thinking of chlorine. Thank you. Iodine is a gas, though. Bromine is a liquid. Thank you. So we're going to look at a problem on station. So this is going to be station number 3. We're going to look at number 1 and number 3. And again, these are double replacement, single or net ionic equation problems. So if we look at number 3 on this problem, what we are told is that solutions of magnesium acetate and water are combined. So we have magnesium acetate, and this would be a 2, and this is aqueous, because we are told that it's a solution. And we have water, and this is a liquid. And then what's going to happen is magnesium, and again, if you think of water as being HOH, we say that we're going to have magnesium hydroxide. And what am I thinking? Combined indicate the solution. This is a solid. And then we have acetic acid, C2H3O2, and this is aqueous. And adding my coefficients, we're going to have 2 and a 2 in front of here. And there's my balanced reaction. So let's go ahead and write out my ions. This is aqueous solution, so it will break off into ions. So we're going to have magnesium with a 2+ charge. That's aqueous. We're going to have 2 of these. These each have a negative charge, and this is aqueous. We're going to have 2 moles of water. Keep that together. Keep magnesium hydroxide together because that's a solid. And then we're going to have 2 moles of hydrogen ions and 2 moles of acetate. That's aqueous. So if we look at this and we start canceling out things that appear on both sides, we see that we're going to be getting rid of the acetate, and that's really the only thing that we get rid of. So when we rewrite this, what we will see is that we will have magnesium with a 2+, and that's aqueous, plus 2 waters as a liquid, and we're going to produce magnesium hydroxide as a solid, and then 2 hydrogen ions. So that would be my net ionic equation for that problem. Again, a little bit more unconventional. We have a liquid and a solid, but this is where it becomes really helpful to write out your all your ions and how they break out, because you might not recognize that you're going to have 2 hydrogen ions over here, or you're going to have your water over here. It's not as clear of what's going on. So let's go ahead and look at number 3 on this sheet. Number 3 says solutions of sodium carbonate and phosphoric acid are combined. So let's go ahead and write out that. So we have sodium acetate, which would be Na2CO3. We're told those are solutions, so that's aqueous. Phosphoric acid is H3PO4. That's aqueous. And then that's going to produce, this is going to be a double replacement reaction. And actually, this is a little bit different because what we're going to be creating is carbonic acid. So we're actually going to be producing H2CO3, but then this breaks apart into carbonate gas plus water. And then we're going to have sodium phosphate, and this is going to be aqueous. So that's a gas, that's a liquid. This is what I'm talking about with one of your rules. So with the process of gas. So we do have those 4 exceptions that you have on your notes where you are given something like this and it will break down and it will form something else. So we have a gas and things like that. Okay, so let's start breaking things apart. We have 2 sodium ions that does not have a plus charge, that has a minus charge or a +1 charge, and that's aqueous, plus carbonate, which is a -2, plus 3 hydrogens, plus phosphate. Oh no, my pen froze. Technical difficulties, you guys. Give me a minute to try to figure this out. Let me see if I can get it to work. All right, I don't know what happened, you guys, so I don't know how well this is going to work now. Let me try one thing. There you go. All right, I got it back. All right, when in doubt, turn it off and on. Okay, so let's go ahead and try this again. So this is going to break up into, we do not want a highlighter, we want a pen. So that aqueous, we're going to produce CO2 gas, and we're going to produce some water. And we're going to, oh, I didn't balance my reaction, you guys. Let's balance this. My bad. Okay, go back really fast. We're going to put a 3 here. We're going to put a 2 here. We're going to need, let's see what else. We're going to need a 2 here, a 3 here, and a 3, a 2, and a 3. Okay, there you go. Now it's balanced. Let's go back and look at this. A rookie mistake. Thank you, you guys. I know. Okay, so let's erase these and go back. So this is actually going to be 6. This is going to be 3. This is going to be 6. This is going to be 2. This is going to be 3. This is going to be 3. This is going to be 6 sodium ions, and then 2 phosphate ions as well. So what we end up seeing with this one is that our phosphates cancel out, our sodium cancels out, and that's really about it. So if we rewrite this, we're going to have 3CO3 with a 2 minus, aqueous, plus 6 hydrogens, aqueous, and we're going to produce CO2 gas and some water. So that is those problems. All right, so let's go ahead and look at another problem. So the other problem that I got requested was the BCA table. So we're going to look at a BCA table. We're going to look at station number 7 for the BCA table. And so we are given that problem. So let's go ahead and look at station number 7. Let's get a blank page. Okay. So looking at station number 7, we are given this equation. We are given N2 to gas. We are given 3H2 gas. And we are given NH3 gas. Okay. So this is what we're given. And I think my pen might be dying, you guys. It's flashing at me. So it doesn't say that it's dead, but it could be dying. We'll see how far we can get. So if we are told that we have 14.0 grams of nitrogen, and we are told that we have 4 grams of hydrogen. And the first thing we're asked to do is convert these into moles. And we are given some molar mass. I'm going to use the molar masses that they give us, 1 mole. And we are told that this is 2.02 grams and 1 mole. So we figure out that we have 0.50 moles of nitrogen and 2.0 moles of hydrogen. Okay, so let's go ahead and look at our BCA table now. So when we start up with our BCA table, we're going to have our reaction up top. And then we're going to have on the side our before, our change, and our after. So our before is starting off with these amounts. So we have 5 moles of nitrogen and we have 2 moles of hydrogen. Now, if you look at this amount, one of the most important things that we have with this is we have these coefficients. So what this tells us is that nitrogen and hydrogen will react in a 1-to-3 ratio. So for every 1 mole of nitrogen that is consumed, 3 moles of hydrogen will be consumed. Now, before, we have 0.5 moles of nitrogen and 2 moles of hydrogen, but no ammonia. Now, our change, we need to figure out which one of these is going to be consumed first. So if we look at this and we say, okay, if we consume all of our nitrogen, we're going to consume 3 times as much hydrogen. So if we consume 0.5 moles of nitrogen, we're actually going to only consume 1.5 moles of hydrogen. So that tells us that hydrogen is going to be in excess. So what I do is I'm going to go ahead and I'm going to consume all of my nitrogen, and I'm going to consume 1.5 moles of hydrogen, because again, it's a 1-to-3 ratio. So I'm going to produce I'm going to consume 3 times as much hydrogen. Well, how much ammonia am I going to produce? Well, it's a 1-to-2 ratio. So I'm going to produce twice as much ammonia. So I'm going to produce 1.0 moles of ammonia. And my pen just died again. Okay, I will try to do this another way. And so what we see right here is this is going to be a plus. This is going to take me a long time to do it this way, you guys. And so what we have right here is that this is going to be 0. And we're going to have leftover. So we're going to have 0.5. And I'm trying to do this with my really small mouse pad. So excuse me while this takes me a little bit of time. Moles, because my pen just died. And then I'm going to produce 1 mole of this. So this is my after. And again, these are not being consumed at the same rate. They are being consumed in different amounts. So because it's a 1-to-3 ratio, we're going to have leftover hydrogen in the end. And so there's that one. Okay. You know what? I wish I could replace the batteries, but this does not have batteries. It's charged with a device. So if I could replace the batteries in my pen, I would. But I don't think it quite works that way with this pen, unfortunately, which is kind of a pain in the butt. Let me just see one thing, you guys. What type of battery is this? It's a quadruple A. It's an AAAA. Yeah, I don't know what that is. I don't have that. So we will try to do as best as we can. So I'm going to plug that back in. Maybe we'll be able to use it for the last part. Okay, let's see. What next? You will not need to do concentration where M is underlined, so don't worry about that. 2G on the redox reactions homework. Let me look at that. Redox reactions homework 2. Wait, which one? 2G? 2G. All right, so let's look at 2G for the redox reactions homework. And this is going to take me a while to write out, you guys. So bear with me. So we have 2G. We have sodium metal is placed into water. So we have sodium metal, so it's going to be Na, and it's a solid. And I'm trying to do this with my, this is not going to work well. This is going to be really bad. Okay, let's try this. So it's going to be a solid. Oh, that's not going to work. And we're reacting it with water. Oh, you guys, this is not going to work. Yeah, this is not going to work. Let me see if I can go back to my pen for a minute. We'll go back and forth. We'll see how long this lasts. Okay, so we have this. I'll go through this quickly and try to get through as much as I can, but I don't think this review session is going to last as long as we hope. So we're going to have some water, and it's a liquid, and what's going to happen is we are going to produce some hydrogen gas, and we are going to produce some sodium hydroxide, and this is aqueous. Balance this out, we're going to have a 2, a 2, and a 2. So our net ionic equation for this one is 2NaS
plus 2 waters as a liquid, and we are going to produce H2 gas. Oh, I see what this one's doing. And we are going to have I don't like this one. Sodium hydroxide. Aqueous plus OH. 2 OHs minus. So what we need to look at is we need to look at our charges that are happening here. So what we see is sodium has a 0 charge and it goes to a plus charge. So what that means is it's being oxidized, so it's losing an electron. So if I write down my oxidation, what that's going to look like is 2 sodium with a solid charge, and it's going to produce 2 sodium ions, and those are aqueous, plus 2 electrons. So that's my oxidation. My hydrogen over here is going from a 0, and right over here it actually has a plus charge. So we have hydrogen going from a plus to a 0, so that is our reduction. And so if we're just looking at the hydrogen, we do want to write this whole thing here. And actually, so we're going to have 2 hydrogen, and they're liquid, and they're going to gain 2 electrons. And we're just talking about the hydrogen. And then they're going to produce hydrogen gas, which is a 0 charge. So that one's a little bit weird. I wouldn't expect you to be able to do that one on a test, but yeah. Replace the ink cartridge. I don't think that I can replace an ink cartridge on the pen, but good idea, Aiden. Thinking outside the box. 2D and 2E on the stoichiometry worksheet. So stoichiometry worksheet, let's go ahead and take a look at that. Let me find that really fast in my folder. D and E. Okay, so 2D and E, the oxygen doesn't participate in the oxidation. Oxygen's not being reduced. It has a -2 charge right there. It has a -2 charge right there. So I'm not worried about the oxygen. The only thing that I'm paying attention to in this one is the hydrogen, because that's the only thing that's changing charges. The oxygen's not changing charges. But I can't just write the hydrogen because the oxygen is attached to there. Okay, so let's look at the stoichiometry worksheet. We are going to look at D and E. And let me see if I can find the answer key, because that has some information on there that I might need. I don't know what happened to my answer key. Okay. So, we are looking at stoichiometry homework, and we are looking at number 2, D, and E. And so what we have with this one is that we have another BCA table. So I'll do this one kind of quickly. What we have is we have calcium chlorate, and it's decomposing, and we are told that it turns into potassium chloride and oxygen. So we need to balance this. This has 3, this has 2, so I'm going to put a 3 here, a 2 here, and a 2 here. And so let's put our BCA table here. Now with your BCA table, you do need to put moles in here. So we do need to know the moles that we are given. So we are told in this problem that we have 24.5 grams of potassium chlorate, and we need to convert that into moles. And I do not have the answer key in front of me, so let me calculate this really fast. We have potassium, which is 39.10, plus chloride, which is 35.45, plus 3 oxygens, so that's going to be 3 times 16, and I get 122.55. So I'm going to have 122.55 grams here, 1 mole on top. And that's going to give me the number of moles that I start out with this problem. So if I round this up, I'm starting off with 0.200 moles. And I have none of this. So when we figure out what our change is, this is all going to be consumed. There is no limiting reactant, so this is going to consume all of this. So I'm going to consume all 0.200 moles of this, and we can see our ratio. So this is consumed in a 2-to-2 ratio. So what that means is that for every 2 moles of this that's consumed, I'm going to produce 2 moles of this. So I'm actually going to produce 0.200 moles of this. And then this one is a 2-to-3 ratio. So I'm going to have 0.2, and just kind of showing you guys the math, moles of KClO3. And it's going to be 2 moles to 3 moles. So what that ends up being is plus 0.300 moles. So if we go ahead and we solve this, we see that this ends up being 0. This ends up being plus 2.00, and this ends up being 0.300 moles. So we have those answers. And so this is D. And so if we look at E, it says find the mass of KCl produced. Well, we know how many moles, so all we need to do with this is convert moles into grams. So we're going to 0.200 moles of KCl, and my pen is dying again. It doesn't like me. And so what we're going to do is we're going to go ahead and we're going to plug in the molar mass. So let me calculate the molar mass for that really fast. We have 35.45 plus 39.10. So it's 74.50. So it's going to be 74.55, and that's going to be, oops, wrong side. Let's erase this. So this is going to be 74. I'm using my keypad again, so give me a minute, you guys, or my mouse pad. This is grams, and this gets really messy. Over 1 mole. So what this ends up being is 0.200 times, I can't even read my own writing. Is that 74.55? So we get 14.9. So my answer for that one is, again, 14.9. Let me go ahead and write this in. 14.9 grams, and that's KCl. All right, let's go ahead and move on to the next one. I'm going to plug my pen in, get that charging up a little bit, and look at the next problem. 2B on the redox reactions worksheet. Okay. So 2B on the redox reactions. Let's go ahead and take a look at that. All right, so 2B says magnesium metal is placed in a solution of nickel chloride. So we're going to be writing out our reaction for this. So let me take my pen out. So we have magnesium, and that's a solid, and it's in a solution of nickel chloride. Nickel is a +2 charge, so it's going to be like this. This reaction will occur, so magnesium is more reactive than nickel. So what's going to happen is we're going to then get nickel solid, and we're going to get magnesium chloride, MgCl2. And this is aqueous. So if we write out our net ionic equation for this one, we're going to have magnesium solid. This is going to have a 0 charge. We're going to have nickel, which has a +2 charge. And we're going to have 2 chlorine, which is aqueous. And then we're going to have nickel solid, which is a 0 charge. We're going to have some magnesium, which is a 2+ charge. Now that's aqueous. And then we're going to have 2 chlorine, which is a negative charge, and that's aqueous. So what ends up happening is chlorine ends up canceling out. What we can see is magnesium goes from 0 to a +2 charge. That means that it's being oxidized. So my oxidation reaction is magnesium 0 solid going to Mg 2+, and it is losing 2 electrons. This is aqueous. Nickel is gaining 2 electrons, so that's my reduction. So we're going to go from nickel with a 2+, aqueous. It's gaining 2 electrons, so that's going to go in my reactant. And then we're going to go to nickel solid. So there is that reaction. Do you need to know the reactivity order of elements? They do follow a pattern, so you can kind of find the pattern. You do definitely need to know the reactivity of your halogens, knowing that fluorine is most reactive and it goes down. But if there's more than that, I will give you that list. So you do not need to memorize it. Are you going to have any where a reaction would not occur, and what would signal that? If a reaction wouldn't occur, when you have an aqueous solution producing 2 more aqueous solutions, that's really not a reaction, and that would not occur. So if you look at, and I think there's one in our review, let me find that. If you look at, oh no, those all occur. But pretty much if you had 2 aqueous solutions that react and you did a double replacement reaction and they produce 2 more aqueous solutions, that's not really a reaction. A reaction has to produce something new. So if it would produce a solid, that would be a reaction. Last one, station 1. Are you going to give us solubilities? Yes, I will give you solubility rules. Who is Al Krill? Who is this? I don't know if I should respond to you. Why don't you guys use your real names on here? It's weird. You guys are weird. Oh, that's Daniel. Daniel is Al Krill, whatever. That's your other account. Oh, okay. Other questions? You had a YouTube channel in 4th grade? Wow. I wasn't that cool in 4th grade. Not that we had YouTube when I was in 4th grade. All right, other questions that you guys want me to review? All the answers to the review sheet are online, so you guys can definitely do that. ENF on reactions in aqueous solutions. Let me find that. E and F. Okay. Let's look at those two. So you're talking about, I'm thinking the homework. So let's go ahead and look at the homework. This is reactions in aqueous solutions homework. So if we look at this problem, so we're looking at E. We are told that we have a solution of lead 2 nitrate. So that's going to be Pb2 nitrate. Oh, why did I write it that way? Okay. Let me erase that. We have Pb nitrate, and we need 2 of them, and lithium iodide, which is LiI. We are told that those are solutions, so we know that they are going to be aqueous. And what's going to happen is lead is going to form a bond with iodine. So what that's going to look like is PbI2. And if you look on your solubility chart, this is actually a solid. So that is going to be an S. And then we're going to have lithium nitrate. And this is going to be aqueous. So if we look at this and we were to write out our net ionic equations, I'm kind of going to do a shortcut really fast to you guys because these are all aqueous. What you would see is that let's balance this. Let's go 2, 2. So what you would see is that your nitrates would cancel out. You would see that your lithiums cancel out, and you're left with your lead and your iodide. So I'm kind of doing a shortcut, you guys. So you're going to have your lead, you're going to have your iodine, and then you're going to have your lead 2 iodide, and that's going to be a solid. So that would be your net ionic equation. And then for F, number 2E. Oh, let me see if I can find those. Oh, okay. So for this one, it's just a little bit backwards. So you're going to have calcium carbonate, and that's a solid. And you're going to have HNO3, and that is aqueous. And what you're actually going to produce is calcium nitrate. And that's going to be aqueous. And then you're going to produce some carbonate gas, CO3, and some water. So this, I don't think that's CO3. I think this is supposed to be CO2. So if we need to balance our reaction, did we see this in class? That's much easier than the mental gymnastics I've been doing. Nicholas, you can use a molar ratio if you have that. I think that it's better to do the stoichiometry problem to prove your work. It's up to you. Ali, if you're given an element like lead has multiple ions, it will be specified in the test. If it's not for some reason, I will let you know.
So don't worry about that. So CO2 and H2O. So let's balance this really fast. Let's have a 2 here. That's going to give me 2. We are probably going to need a 3. Oh, this is going to be a pain in the butt to balance. Oh no, that's 3. That's 2. Okay, it's balanced. Okay, so we're going to have, what we're going to have is, the only thing that's actually going to cancel out is our nitrates. So what we end up having is calcium carbonate as a solid plus 2 hydrogens, aqueous, and we're going to produce calcium, aqueous, plus some gas, plus some liquid. So that's what we're going to produce with that one. And that's kind of the same thing with the next one, where you would be producing cesium acetate and some water, and the water wouldn't break apart. And again, my pen's dying, so I'm trying to avoid having to write too much, but a very similar problem. Those really are the more tricky ones. And on the test or quiz, you're going to be really focusing on things that you might see on the first page. So I'm not going to, don't worry too much about those kind of really off the wall ones. So we still put charges on single elements in the product like calcium. You still put a charge on that because it has a charge because it's bonded to the nitrate. So you still want to make sure you put a charge on that. Calcium carbonate does not have a charge because that's a solid, and so it doesn't break apart. So that does have a charge on that. I like that Aiden is giving a little, what do we call it? A public service announcement with his emojis there. That's good. I think Aiden's saying that if you smoke, you die. Don't smoke, you guys, according to Aiden. Smoking's bad. Other questions? Looking at our review, let me look at one thing. Let me bring something else up really fast. Actually, I don't think I have it here. So when you're reviewing, you want to be able to definitely know the types of reactions. So be able to identify things as combustion, decomposition, double replacement, single replacement. You'll need to know how to predict reactions. So if you have a combustion, how are you going to predict that product? If you have a decomposition, what does that look like? If you have a double replacement or a single replacement, what do those look like? So you want to be able to predict those products. That's really important. You're going to want to be able to write out net ionic equations. So breaking things up and canceling out your common ions. You are going to want to be able to identify what's being oxidized and what's being reduced. You are going to need to use a BCA table, so know how to use a BCA table. Now, if you're not 100% comfortable using the BCA table, you can always do math, so doing your ratios, and then plug that into your BCA table. And then you are going to need to know and solve a problem with your limiting reaction, calculating your percent yield and things like that, showing your work to make sure that you are proving which one's a limiting reaction and which one's not. And of course, there are multiple choice problems. Those multiple choice problems, same ideas. So if you look at the
kind of things that you're doing. Daniel, why are you thinking about the end? We're not even there. I don't know how many more chapters we have. We're just going with the flow. Do you have to, or do we just consider that naturalization reactions? We haven't talked about naturalization. Oh, neutralization reactions. Neutralization reactions we will call double replacement. So we haven't specified those as being anything different. So they will be just double replacement. Let's look at one more redox reaction. So 1E. Let's look at 1E. Okay, 1E, and this is going to be redox. Okay, so we are given the reaction 2MgO solid. Why is this not working? Hold on one second. Let's try this again. 2MgO solid. We're going to produce 2Mg plus O2. So let's look at what happens here. We're told this is a solid, this is a gas. It really doesn't matter too much. But let's go ahead and apply charges. This is an ionic compound, and in an ionic compound, these have charges. Magnesium has a +2 charge, and oxygen has a -2 charge. Magnesium as a solid, this is in its elemental stage. And remember, anything in its elemental state will have a 0 charge. So this has a 0 charge. Oxygen right here is also in its elemental state. So over here, we're going to have a 0 charge as well. And so let's identify what's happening over here. So notice that magnesium goes from a +2 to a 0. So what's actually happening to magnesium is actually gaining 2 electrons. So if it's gaining 2 electrons, that means that it's being reduced. So magnesium is going from a +2 to a magnesium with a 0. If we were to write that half reaction, we could put the 2's in front of there. Each magnesium is gaining 2 electrons, but magnesium total for both of these is gaining 4. So it would be 2Mg plus 2, and it's gaining 4 electrons. And we're going to be producing 2 magnesium with a 0 charge. Over here we have oxygen, and oxygen is actually going from a -2 to a 0. So this is actually losing electrons. So that's going to be oxidation. So we have 2 oxide atoms, and that's a solid. And we are producing oxygen gas, which is neutral, and it's gaining or it's losing 4 electrons. So again, with these problems, it's important to note that the electrons gained by one thing are the electrons lost by another. So you definitely want to make sure that that has the same amount. You might need to, and when you combine half reactions, you pretty much just write them together, but don't put the electrons in there. So if I were to combine this reaction, so if I were to write a, whoops, that was weird. If I were to have a combined reaction, I would just put everything over here and note that these electrons cancel out. So I have 2 magnesium with a +2 charge, 2 oxygen with a -2 charge, and it produces 2 magnesium oxides plus oxygen. So that's really my combined reaction. And again, you're combining them, you're showing that the number of electrons cancels out in your combined reaction. So hopefully that makes sense. Any other questions? I will be there tomorrow during tutorial, so if you guys do have other questions, feel free to stop by. A pretty low turnout today after school. I was actually kind of surprised. I saw a total of only 6 people, so hopefully you guys feel ready for the test. I am going to give you pretty much the entire period to do it, so make sure that you guys are ready. And you also want to have your homework, and you have 5 homework sheets. You have, I think one's called Identifying Types of Reactions, Aqueous Solution, Redox Reactions, Stoichiometry, and Limiting Reactants. So make sure that you put those together. Aiden, when you say are solids, liquids, and gases by themselves always neutral, if they're in their elemental state, they are neutral. So for example, magnesium, in this example that I have on the screen, is in its elemental state. Diatomic atoms, like oxygen, bromine, fluorine, are also in their elemental state, so they are neutral as well. I don't want to say that all of them are, because things like water is not. So that would not be neutral. You can identify oxidation charges on there. I didn't stamp anyone's limiting reactions worksheet, so don't worry about that. You're still going to turn it in. As long as it's completed, you will get your full credits, but I did not stamp that. All right, so I'm going to go ahead and call it a night, you guys. Again, if you guys have questions, bring them to me tomorrow during tutorial. I will be in class. I will probably be there a little early, so if you guys are there at 7:15, stop by. If I am in the room, you're more than welcome to come and ask questions. So feel free to come by and ask questions if you guys are around. Other than that, I would just make sure that you review your homework. Make sure you also review the review that I posted on Google Classroom. The answers are also posted for that as well, so make sure you guys review that. I hope you guys have a good rest of your evening, and I will see you tomorrow.